Okay, sometimes you have an equation like this where you have variables. We're still with one variable and they're all x's. But if you notice, a couple of the x's are on the same side of the equal sign, or what I call the tennis court side. So we always want to combine like terms first. A term is like these guys here. Each of these is a term. They're usually separated by a plus or a minus. We call these monomials as well. All right, monomial is really just is a term. All right, so we're going to combine like terms. So the first thing, and I'm going to highlight them, is I see a minus x, then I have a minus 6x. If I was to combine those, a minus and a minus, remember there is a 1 in front of that x because I had 1x. So I have a minus 1 and a minus 6, which makes it a minus 7x. Okay, now that I've combined my like terms on my left side, I look over to my right and I didn't have anything to combine. They were basically simple. Now we're going to get the variables on one side. So we're going to get x on one side of the equal sign and we're going to get the numbers on the other side. And that's what our goal is here. And it doesn't matter. I can put the x's over here if I want to and the numbers over here. It doesn't matter. It's just a process that we do, that we follow. Alright? And so we're going to look and we're going to move. I like moving my numbers over first, and so I'm going to take negative 7 and I'm going to subtract it to both sides. Alright, when I do this, I end up getting negative 7x. This becomes a zero pair equals 12 minus 7x. Now I'm going to move my x over to the opposite. So remember what we talked about before is that because I hit my 7 over here, now, you know, the easy serve, now I got to move 7x over on the other side. So instead of a minus 7x, I'm going to add 7x to both sides. Now something interesting happens here. I have a zero pair here, but I also have one here. Okay, this is a special case. And what is a negative 7 plus 7? And because we have to do this, we're going to have to put 0 here because there's nothing over on this side of the tennis court net, or the equal sign. Now over here, this becomes 0, so we're okay, but because we have a 12 here. Now if you notice, I have no variables. All I have is 0 equals 12. And does 0 equal 12? No, it does not. Whenever you have a situation like this, we call this a no solution. No solution. Alright? So whenever you do it and the variables kind of cancel each other out and all you got is numbers, you look at them, see if they're equal. If they're equal, then you got something special. But if you don't, then it is no solution. Now, if these guys did equal, and we're going to talk about this now, if you ended up with something like that, then this would be an infinite set. Alright? Infinite set means they're like kind of like on top of each other. Basically, that's what it means. Alright, this one would mean they're kind of separated. Okay, if we were talking about a linear system. But in this case, we have no solution because in this case we have a no solution. So, like I said, since this is a no solution, there's no value for x that will make these two sides equal. So this side here, the equal sign here, this side, nor this side, there's no number I can put in there to make them equal. Okay, so I thought we'd try another one, and so I wanted to try one like this. All right, so here we go. Okay, so here's a problem. I threw a distributive property in here on you, so that way we can practice this a little bit. Alright, so the first thing I do is I need to distribute. I mean, I got to do that because I have a number outside the parentheses and it needs to be distributed. So I'm going to multiply 3 to the 2, and then 2 to 3x, and then 2 to 1. So here we go, we're going to get started. So I'm going to say 6x plus 2 equals, and then 2 times 3x is 6x plus 2. Alright, and then I'm going to subtract both sides by negative 2. Right? Notice this becomes a zero pair. Well, so does this. This becomes a zero pair. So it ends up I have 6x equals 6x. Alright? And notice that they're the exact same thing. So even if I went ahead and subtracted 6x to both sides to try to balance, get them all on one side, I'd still end up with the same number, so it'd be 0 equals 0. All right, when this happens, this solution is called all real numbers. So all real numbers. Okay, that means any value that I plug in for this x and the same number in this end, they will always be equal. Any number. So I could put 0 in there, I could put 1 in there, I could put 2 in there, it doesn't matter. So like, let's say I put 0 in there. Okay, so 0, that would make it 2 on this side. If I put this would make 2 times 1, which is 2, so that would be 2, that would be 2. If I put 1 in here, this would be 8. If I put 1 over here, it would be 2 times, that would be 4, because I put a 1 in there, 3 plus 1 is 4, and that would be 8. So it doesn't matter, no matter what numbers I put in there, alright, whatever numbers I put in there, it's going to work. So all the possible numbers can work. That's why it's called all real numbers. So, like we discussed before, remember what we talked about, I did the video just not too long ago, is that when the variables are gone and you just have numbers, if they are true, so if 0 equals 0, then it's all real numbers. But if they're different, then it's no solution. It means no numbers will work, where all numbers will work. Okay?